Hello everyone, my name is Sushil. I have 12-year experience in CA automobiles crash and safety. I have worked with 3 MNCs. I have experience of OEMs also. Welcome to the certification course in HyperMesh. HyperMesh is a pre-processing software. In CAE, there are 3 phases: preprocessor, solver and post-processor. The very first step is pre-processing. CAE is nothing but computer-aided engineering. In this course, we will be focusing on preprocessor. We will be studying HyperMesh. In preprocessor, we will learn geometry creating, geometry cleanup, 1D meshing, 2D meshing, 3D meshing. Along with that, we will do quality checks, connections, boundary conditions, solver deck preparation and analysis. First of all, we'll see introduction to FEA. So on behalf of G2G Innovations, I welcome you all. So introduction to FEA. What is FEA? FEA is nothing but finite element analysis. In FEA, what we'll do, we'll divide the complete component into number of finite small elements which will have nodes. Okay, so number of nodes is equal to 8. Here we can see. Okay, degrees of freedom per node is equal to 6. So total number of equations will be 48. So basic theme of FEA is nothing but dividing the whole structure, whole component into number of small elements. Okay, I will show you this with example. Suppose I take one bar. Which is having force F at one end. Okay, so what I will do, I will divide this into two elements. Suppose this is 1, this is 2. Okay, so how many elements are there? There are 2 elements and number of nodes are there. This is 1, this is 2, this is 3, n1, n2, n3. Okay, so there are 3 nodes. So nodes will carry always mass. So what will be the stiffness matrix? Stiffness. So what is stiffness? Stiffness is nothing but force upon displacement. Okay, so our universal equation becomes F is equal to stiffness into displacement, where F is equal to force, K is stiffness and U is the displacement. Okay, so stiffness matrix for first element will be K1, which is will be equal to K1 minus K1 minus K1 K1. Stiffness of second matrix will be equal to K2 minus K2 minus K2 K2. Okay, so this is formation of stiffness matrix. The other step in FEA is formation of global stiffness matrix. So according to this, okay, so this is one dimensional problem. Okay, so degree of freedom at each node, as we have seen, like here, degree of freedom at each node will be 1 and number of nodes are 3. So a global stiffness matrix, therefore our global stiffness matrix will be K1 minus K1 minus K1 K1 plus K2 minus K2 minus K2 K2, remaining elements 0. So this is nothing but our global stiffness matrix. Okay, what will be the other part of global stiffness matrix? After that global stiffness matrix we will put up in this. Suppose this is equation number A. Okay, we will put up our global stiffness matrix in equation number A. So here what will be the displacement and force at this point will be U1 F1, at this point will be U2, sorry, U2 and F2, and at this point will be U3 and F3. Okay, so we'll write that equation. F1, F2, F3 will be equal to global stiffness matrix K1 minus K1 minus K1, K1 plus K2, K2, this is minus K2 minus K2, K2. Rest all diagonal elements 0 into displacement U1, U2, U3. Okay, so next step in finite element analysis is boundary conditions, applying boundary conditions. So let me take you to the figure again. See, what will be the boundary conditions here? At this point it is rigidly connected, so U1 will be 0. Okay, so U1 will be 0, so eliminating first row and first column of stiffness matrix will solve for U2 and U3. Okay, then we'll get displacement. After getting displacement, we'll calculate for strain and stresses. So this is nothing but finite element analysis. What we did, okay, first we divided our problem into two elements. Okay, this is very basic, so I'm explaining it as a basic, which will having three nodes n1, n2, n3. Two elements are there, so for each element we will have stiffness. Okay, so we have formulated stiffness matrix, then we have formulated global stiffness matrix, then we have utilized a universal equation, that is equation number A, force is equal to stiffness into displacement. Force is equal to stiffness into displacement in matrix form. We have applied boundary conditions and we have calculated displacements and strains and stresses. Okay, so again I will put up one example of HyperMesh. We will see a HyperMesh software, just a glimpse of it. Later we'll learn it in detail. So this is how the GUI, graphical user interface, of HyperMesh looks like. Okay, so here I have one component. Okay, so just now I have explained that finite element analysis. So what I will do, I will divide this into number of small elements. See what I mean? Creating a mesh, the very first step of FEA is discretization, means meshing. So this we are going to learn in HyperMesh. See, multiple areas I can mesh. Okay, so this is 2D shell mesh. Here two types of elements will be there. We'll see elements, type of elements in detail: quad element and tri element. So this is nothing but meshing. This is nothing but, what is this? Discretization. Okay, the very first step of FEA. So again, coming back to our PPT. Okay, so this we have just seen. Dividing means discretizing and then calculating for equations. Okay, so this is nothing but meshing, our first part, preprocessing. So types of elements will include 1D. 1D, what will be the 1D? Okay, in one dimension will be longer than other two dimensions. Okay, so that is nothing but 1D. Other two dimensions will be negligible. Okay, so element shape, line is there. Element type, rod, bar, beam, pipe, axisymmetric shell. Practical applications include long shafts, beams, pin joint connection elements, etc. So 2D elements, which we have seen just now in HyperMesh, it will be like in one plane. Okay, one dimensional will be, the thickness dimension will be very less compared to the other two. So element shape will be quad and tria. Just now we have seen here, see, quad elements and tri elements. Okay, so this is nothing but 2D meshing, shell meshing. Okay, and other we have 3D. Okay, 2D meshing practical applications are sheet metal parts, all automobile components, whichever are automobile interiors other than seat foams and all, instrumentation panel, the dashboard, we call it as instrumentation panels, will come under 2D. Okay. Other element type is 3D. All dimensions are comparable. Okay. Element shape will be tetra, penta, hexa, pyramid. So automobile applications for this will be overhead systems. It will be modeled as hexa. Okay, again crankshaft, engine components, suspension will be solid. Okay, it will be modeled as hexa and tetra. Seat foams will be modeled as tetra. So these are practical applications. And other elements are like rigid body elements that will be used to connect two components, weld elements. Okay, so those will be like simple mass damping damper, spring mass damper. Okay, spring, translational and rotational stiffness will include. Okay, so these are the types of elements. Okay, then again I will have one question, that how will I decide the type of element. Okay, so it will totally depend upon the geometry size, time required for calculation. Okay, so finer mesh will require more time for analysis, runtime will be more, and coarse mesh will require less time, less runtime. Okay, and also type of analysis, whether it is drop test, impact test, frontal impact, rear impact. So this will all factors depend on choosing type of element and the size of the element. Okay, element edge length. Okay, so this we can decide into like previous gateways, references, previous base experiences, and the type of analysis what we are going to perform. So steps to begin meshing. So what will I do if I get one component to meshing? Spend sufficient time in studying the geometry. How is the geometry? How are the curves? How are the holes? Okay, washers and all this we have to study. Take sufficient time. Time estimation. Suppose you are having one complete assembly. What will be the time required? Time estimation to complete that assembly. And if you have 3 engineers to work on, so how will you divide? So that things need to be considered. Geometry checks, free edges, scar lines, duplicate surfaces, small fillets, that we'll study one by one. What are those in our upcoming projects? Symmetry check, selection of type of elements, type of meshing. Joint model. Joint model means we'll use rigid bodies and other weld connections to connect the model, connect the components, to assemble the components rather to say. And splitting the job. Again, if you have team, okay, how will you split the job, how will you divide the job, okay, and how will you assemble the complete sub assembly. So this was all about steps to begin meshing. Thank you for watching this tutorial. We will meet in next tutorial.